Good morning, students. Once again, and how are you all? I think so fine. And today we are continuing the next class, that is electric potential and electric potential difference. I think so. It is very clear to you the difference between electric potential and electric potential difference, and the formulas also I told you, and the units I expressed. And I had gone through differences between scalars and vectors, and which is a scalar quantity, which is a vector quantity. And I told you that volt is the SI unit for both electric potential and potential difference. Now we are going to learn about much in detail about this one. What is the further formulas? What is the further concepts on this electric potential and potential difference? And suppose if you take here plus q charge, and this is the surrounding field. Okay, and here I would like to bring here the test charge q from r and to this point p, and here this is the positive charge and this is a positive charge, and which force exists? A repulsive force exists. So to overcome that we need to apply some external force. This is the external force we have to apply. So when we are moving a charge from here to here, the acceleration of the charge of the test charge, it is 0, since we are doing the work and that is stored in the form of potential energy, that is called electric potential energy. So here the potential energy, it is ur, and here the potential energy, it is up potential energy of the system. This is ur and this is up. And just like gravitational force, electrostatic force is also a conservative force. In class 11 I already teach you about the conservative force, about the gravitational force there, and this conservative force does not depend upon the path followed. It depends only upon the initial point and the final points. That is, if the work is done by the electrostatic force, the work done does not depend upon the path followed. Okay, let me clarify this one. So okay, here work is done by the electrostatic, work is done by the conservative force. It does not depend upon the path followed, and to this is the initial point and this is the final point, and we can go like this directly, we can come like this, you can come like this, and you can come like this, and it does not depend upon the path followed. Here it is, whatever the path you may choose here, the net amount of work done, it is 0. This is the meaning of work done by the conservative force does not depend upon the path followed. It depends only on the initial point and the final position. So that is why the work done W is equal to work done on this per unit test charge. This is UP minus UR. And have you remember, I think so, work done by gravitational force U1 minus U2. And like that, this is UP minus UR. And this work done per unit of charge, this is called here the potential. This is the relation between potential difference and the potential electrostatic potential energy. V is equal to UP minus UR by Q. This is the potential difference. The potential difference between these 2 points, this is V is equal to UP minus UR by Q. UP means potential energy at this point and UR means potential energy at this point by Q. Already we calculated, we know the formula for potential energy between two charges, that is 1 by 4 pi epsilon naught Q1 Q2 by R12. This is the thing. So here the main concept is, like gravitational force, electrostatic force is also a conservative force. So based upon this, so electrostatic potential difference between these 2 points is equal to UP minus UR by Q. Okay. So here in this class we are targeting two things. The first one is potential due to a point charge, and second thing is potential due to a dipole, electric dipole. Okay, let us I will come to that point dipole later, and first of all we'll learn electric potential due to a point charge, and previously we learned electric field due to a point charge E is equal to kq by r square. So like that we are going to learn electric potential. So for this one here I'm taking a point charge, that point charge plus q here, and this is the electric field. We know the definition of the electric potential. The work done per unit test charge to bring it from infinity to a point inside the electric field against the electric field we have to do. And this is the direction of electric field. Why? Because of this is a positive charge and here is a test charge. This is also a positive charge and repulsive force will be there in this direction. So we have to do external force. We have to apply like this. The amount of work done per test charge to move from infinity to this point, that is called electric potential at this point. And let us say that this is a distance of r. So while bringing from q from infinity to this point, there are many intermediate points are there. There are many intermediate points are there. So I'm choosing that one important intermediate point, that as the p dash. P dash is the intermediate point between the infinity and this point, and this distance is from q to p, it is r, and from here to here it is r dash. So at this point, at this p dash, at p dash, electrostatic force is, we know Coulomb's law, 1 by 4 pi epsilon naught q1 q2 by r square. This is the distance. This is the electrostatic force. But we have to calculate what is the work done by the electrostatic external force. We know the relation. External force is equal to minus electrostatic force. Why? Because of both are having same magnitude. So F external is equal to minus 1 by 4 pi epsilon naught r dash square. Now we are going to find out work done by external force. This is only called here potential to move it from infinity to this one. This is generally, since this is electrostatic force is a variable force, so work done by the variable force formula we know F external delta dr prime. Dr prime. Okay, you may have doubt what is meant by dr prime. Dr prime is the smallest displacement. Smallest displacement. So from where to where we are moving, from infinity to this point. So here we will substitute lower limit from infinity to a point P here. What is the distance here? It is r. So here delta r prime is the variable. Okay. Now I am continuing the derivation. W is equal to integral infinity to r. F external is nothing but previously I wrote minus 1 by 4 pi epsilon naught by r prime square into dr prime. This is square. W is equal to, I am bringing the constants outside, integral infinity to r 1 by r prime square into dr prime 4 pi epsilon naught, and we know integration of this 1 by r prime square, it is the minus 1 by r. So here I forget minus infinity to r. So here I am writing Later on you copy neatly this one. This is minus into minus, it will be plus 1 by r infinity to r. First we'll substitute upper limit minus lower limit. 1 by infinity means 0. So here w is equal to 4 pi epsilon naught into 1 by r. And bring this q this side. W by q is equal to 1 by 4 pi epsilon naught q by r. This is the formula we got. I am writing freshly here. Bring this q. W by q is nothing but 1 by 4 pi epsilon naught q by r. And this W by q is nothing but, what do we call? Electrostatic potential. This is V. So the formula electrostatic potential due to a point charge. This is a point charge at a distance r. This is V is equal to 1 by 4 pi epsilon naught into q by r. Don't get any confusion between electrostatic field, electric field, and the potential due to a point charge. Already we got electric field due to a point charge E is equal to 4 pi epsilon naught into q by r square. This is electric field due to a point charge, and this is potential due to a point charge, and here V proportional to 1 by r, whereas electric field changes like 1 by r square. Suppose if you plot a graph here, E r V on y axis, here I am taking an x axis, here I am taking r. This is V proportional to 1 by r, and this is E proportional to 1 by r square. So there is a variation in graph. Why? Because of this depends upon this changes as 1 by r and this changes as 1 by r square. And this is electric potential due to a point charge. And next one we are going to learn electric potential due to a electric dipole. Today class somewhat lengthy, so it will take some more time.